Well, hi, good morning, and thank you so much for joining me here in my shop on October 27th. Another gray, rainy day, but oddly warm here. It's going up to 20 degrees today, and that's quite a bit warmer than it would normally be. So, okay, what about the radio? Well, I think my next target is going to be this capacitor, this one, and this one. And I can't even see this one hidden back here. Maybe we'll go after this tough guy first here. Radio's still humming. I have minimal hope of solving the hum by doing this, but maybe it'll happen. This capacitor appears to be associated with the tone control here. I don't think that's going to cause a hum, but this one, these big ones, there's one back here too. I don't know. Yeah, let's go after this one first. You can start by looking at the diagram. As you can see, I've acquired some assistance here in working on this radio. So let's look at the position of this capacitor. It's located in between the band switch and this coil. I'm pretty sure that's a coil inside there, transformer of some sort. There's another capacitor right here, and there's a capacitor down here. There's another one here, another one here. All those metal odd capacitors. I didn't realize there were so many of them. Just from the angle that I'm looking at, I'm missing some stuff here. So anyway, that's where the capacitor is jammed, in between, just south of this abandoned capacitor here. Okay, Shadow, we're going to go take a look. Okay, so here's the radio. Here's the abandoned capacitor. And here's a capacitor. Whoops, let's zoom in on this. C850, well, looks like picofarad is what it looks like. That would be that small brown one. Where's this other one? Where's the other one? I wonder if it's attached to this, if it's grounded on this point here. Let me look and see what's happening. It is. It is tied to a ground that's, this appears to be on the back apron, but in fact it's tied to a ground lug here. So we have a capacitor going to the chassis, and the other lead is coming up to that tube. I'm looking at it right now. Oh, not a tube. Oh. One, two. What's happening here? 1, 2, 3. It's a 7-pin tube with no key. We'll have to take a closer look at this in a sec. Sorry, I'm leaving you looking at the diagram right now because I'm coming back to it in just a second here. So I don't know how to count the pins. I don't know how to count the pins on this. Well, I know where it is located. It's also 2 resistors connected together at that location. So we're up here. There's a resistor, 2 connected at this location. This is the capacitor here. And there it is, connected to that ground lug, which is actually down here. So there it is, a 0.1. They're showing it just floating out here, but in fact it's been installed right up along here. Again, it's got this wire of this sort, and then just a regular wire. How does that fit in? Well, you know what? There's a very heavy wire, a heavy insulated wire, or something unusual about it. This wire. Okay, let's go look at the radio. I'll show you this stuff. And the purring machine going here too. Okay, so here's what we were just looking at. Yeah, keep an eye on that cat. So this is the capacitor I'm going after here, and this heavier wire, let's note it, would be this wire here, this heavy thing. What is that? It's just a covering, isn't it? Yeah, it's just a loose covering. I don't know why they're showing certain wires to be different than others yet. I haven't figured that one out. So they're showing it just coming down through here and then connecting to ground down there. So you kind of have your choice, I guess. You got to get past this thing. You come down this side of it or come down this side of it. And it is a little tight right in here to get in behind there. But I'm sure I have my choice of what I want to do. A 0.1. Let's find it on the schematic now. A 0.1. Something a little funny here on my screen. Yeah, okay, we'll just... Yeah, well, what's funny is my hand is frozen here. I don't know why that is. Okay. But, whoops. Oh. You're not what? Something's gone wrong here. Something has happened. Okay, forget the radio. I've got to sort out the computer problem here. Oddly enough, that camera's working. I don't get it. Just a sec here. Cameras are working, screen thing not. Okay, let's stop. Okay, well, I'm not sure what was happening there with my computer, but anyway, I've sorted it out now. So what we want to figure out is what is this capacitor doing? So no, it's this one. We know it looks like C10. C10.1. So let's find C10.1 on here. C10. So 10 is a C6, C9, C10. Bypassing a 600 ohm resistor. Okay, bypassing a 600 ohm resistor, and that's probably, there were two, yeah, see these two are right in series here. 600 ohm one is the one this is across. We should read the resistance, 600 and 60,000. And then we'll continue with the change of this capacitor. 660,000. Okay. Are you upset because you can't go outside today? Is that what it is? $660,000. These two blue resistors up here. $67. I'm on the 600,000 scale. Well, that looked more like... There's our 600. Just under 600. And then the other one should be 60,000. 60,000. 67,000. Okay, good enough. So I'm just going to cut that capacitor out of there. Now I suppose as a bypass capacitor, leaking might not be a big deal because there's not much voltage or pressure on it. Get my cutters all the way in there. Apparently, yes, something got cut. Yeah, it's the capacitor. capacitor, all right. What's so special about this tube? Nothing. And they're just showing where they slid covers on to what would be bare wires. Can't read anything on this. So 0.1, eh? Let's give it a try. Anybody willing to bet this is a good condition capacitor? Anybody got money for that? Because I'm betting the opposite. What about you, Shadow? What do you think? Any thoughts on this? She's just watching what I'm doing very intently. Maybe they're jealous of our hands. Okay, watching the magic eye. I might just shade it a little bit. Here we go. It's opened up. It's opened up about 3/4 on 50 volts. 150 it's not going to open, of course. Well, not as bad as I thought. I would have lost my bet on this one, I think. Maybe I would have lost half my bet. Okay, well, I'm quite surprised at that. But it's not a hard-working capacitor. Maybe that makes a difference. Maybe it's in a cool part of the radio as opposed to a warmer part, so it's done a little better. Okay, I'm going to put in a 0.1 replacement for this. Probably going to install it down the same location. All I got to do is get to the chassis. You know, there's a chassis ground right here. Why wouldn't I just go over this way? Or go right over the top of here to here? That's a good question. Why wouldn't you do that? Another possibility is right onto the side of this can here. There's a bit of solder right there, but probably not the best choice. Okay, well, I got lots of options here. I will stick a 0.1 capacitor in there. Well, I got distracted by having to sort through a whole pile of NOS capacitors. But that aside, I've put a new capacitor right in here. And, you know, this is a bypass, a cathode resistor bypass. Why don't we do the other cathode resistor bypass capacitor, which I'm pretty sure is this one. It says 0.1 on it. Let's take a look at the schematic here. And well, first we'll look at the layout and see what the number is on that capacitor. Okay, so we're looking at the layout, and the capacitor in question is this one right here. Okay, made a bit of a video mistake there. Hope I've corrected it in the editing process where I was talking about this diagram but not showing it to you. So the capacitor I'm interested in is this one right here, C20. It shows it under a clamp, but there's no clamp in the radio. It shows one lead going to a chassis terminal here. That's true, and the other lead goes over here where it encounters a 600 ohm resistor also going down to the chassis. This is the cathode resistor, and this is the bypass capacitor for it. We should measure the resistance of this guy here, and when I look in the radio, which I'm doing right now, I see that it looks like there's a connection between here and here. Or maybe it's from here to here. Maybe that's what they've done. Maybe this is a spare and they've utilized it. So here's the shape of the base, and here's the center line of it. So we're north of the center line is where the connection should be. Now I'm going to look myself. It doesn't match. It doesn't match. We've got, it's not this shape. 1, 2, 3, 4, 5, 6, 7, 8 connections. Count them again. 1, 2, 3, 4, 5, 6, 7, 8 connections. Okay, let's look in the radio here. So I'm talking about this guy up here. You know, it's another. It's another mistake I almost made. I almost said, but stopped just short of actually saying the mistake. So I didn't say it. So I don't have to say anything. So stop talking. The shape of this is completely round, and this capacitor is hooked up to this terminal, which is below the center line. The next terminal over is connected to it. Something's going wrong here. And then from there, there's a resistor connected to that goes to ground. So this capacitor ties to this pin, follows this resistor to ground. Now that's going to be the 600 ohm resistor, I'm sure. Why is this radio so different from the info? Okay, so we're looking for 600 ohms. 540. That's close enough. It's not even high, it's low. Okay, why the difference? Now, maybe the difference is immaterial in the end. This capacitor is tied to the pin. See, I wish I could count these. It's another big whopping capacitor tied to the next pin over. Is that true on the, let's look at this diagram. Look at this layout diagram again. So let me turn this the same way the radio is. That'll help my brain a little bit. So what we're seeing is this capacitor lead. See how it's tied to a connection above the center line. And the next connection down doesn't seem to tie to a big capacitor anywhere. What's this? There's another large capacitor coming down from one of these two pins. This isn't adding up. It's another weird situation. Now this looks like a piece of wire with a cover on it. That's how I'm interpreting this. See, does that exist? There's no piece of wire with a cover on it. Something's going wrong here. Something's going wrong. Now, just to make sure I'm in the right zone, I just read the 600 ohm here. That's definitely what's there. But this capacitor ties to this pin. And this pin is connected here. It's just different. What about the next one up? Is it empty? The next one up is... No. Oh, what is going on? Why is this all different? So see, this is the regular arrangement. Here's the resistor and the bypass capacitor, and both going to ground, and they're tied to this pin. Maybe the thing is just rotated in the radio a little bit. That would move the empty pin over to here. If you just rotate this whole thing, that doesn't solve anything. There's a short in here. Or did I not see it right? Let's look with the close-up camera. Maybe I'm just not seeing what's really there. Okay. So this is the capacitor I'm talking about. Oh, the automatic focus is back on again. And you can see it attaches here, which is below the center line. The first pin above the center line is connected to it by a short piece of wire. And then this goes up to the resistor, which is up in behind here, the blue resistor, which goes to ground. And this capacitor comes down. You can see the connection. Oh, look at that. That's a replacement. You can see the connection right in the middle of the wire. That's the style I use, the hooky technique. Just go in the wrong place? Camera, stop refocusing, would you? Any chance this socket's been rewired? Sure doesn't look like it, does it? The wires all look like they were there from the start. I don't really see anything funny going on. So now again, I found some differences between the schematic and the layout diagram. Maybe this is another one. We have to identify which pin is which here. Now, some of these pins should be fat. It would look like the two near the top there are fat. And then we would count around, starting with, let me point at it. So I think these two guys up here are fat. I'm going to count that guy's number 1, 2, 3, 4, and 5. What are 4 and 5 in this tube? And what tube is it? 4 and 5. Oh, it's all covered up. 4 and 5 in that tube. Okay, let's see if I can sort this out. 4 and 5 in that tube. Let's take a look at what tube it is. 4 and... Oh, wait a minute. Wait a second here. This says IF. Whoa. They mean IF tube. They must mean IF tube. Yeah. Because these are the transformers. Okay. Wow, almost had a heart attack there. Okay, so IF. I don't know why they wrote IF there. What tube is this? Give me the name. Come on. That doesn't even. They didn't bother writing it on this. Okay, so it's the tube between the IF. Around we go. So here's the IF tube, 6K7. So we just take a look at it. See, they didn't put the tube pin numbers here. So we can't do anything with this. We will have to look it up. 6K7. I can't remember the pin numbers. I was interested in 4 and 5. 4 and 5, I think. Okay, let's get the book out. Let's get the book out for a 6K7. 6K7. Remote cutoff pentode, metal type, and glass octal type. 6K7G and 6K7GT used in RF and IF stages of radio receivers, particularly those employing AVC. Outline section. These tubes require octal socket and may be mounted in any position. Blah blah blah. For electrode voltage supplies and application, refer to 6SK7. So, but here's the pin layout. So we count 2, 3. So 4 is the screen and 5 is the suppressor. Let's start again on this counting here. So we go 1, 2, 3, 4 has the capacitor. 5, 4 and 5. 4 and 5 are tied together. 4 and 5. Ooh, that doesn't make sense, does it? Does it? 4 is the screen and 5 is the suppressor. You don't put those together. It's a mystery wrapped up in an enigma. So maybe I'm counting the pins wrong. So on the layout diagram, it's going to show me where the heaters are and which pins are. Therefore, it'll identify the heaters. Let's go there. Layout diagram. Let me turn this again so we're seeing it the same way. Here it is. Now, who here is a heater? So the heater is probably this twisted pair coming in here. One goes here. And the other one goes here. Well, that's not. There's no fat pins in this tube. It's an 8-pin tube. Pin number 6 is omitted. I thought thought I counted 7. What am I just nuts? 1, 2, 3, 4, 5, 6. 6. 8. 6K7. Oh my gosh, I left the wrong diagram up there. I did it again. Okay. Sorry about that. So what I did was I counted these pins. 1, 2, 3, 4, 5, 6. It's a 6-pin tube. 6K7 is an 8-pin tube. Wow, what is happening? What is happening here? It's very, very faint here. The writing is right there, but it's very, very faint. Let's see if we can see it. What tube is in here? It's right beside my finger here. Looks like 56 or something like that. Something D6. Oh my gosh. That looks like a D, alright. D6. Let me try different lighting on it here. $6D6. A $6D6. $6D6. $66. $6D6. I don't know if I've ever encountered that particular tube. 6D. Is there such a thing? 6D6. Remote cutoff. Glass type used in RF or IF stages of radio receivers. Tube requires 6 contact socket. Of course, because it has a grid cap on the top. Refer to type at 6SK7 for general application information. So a 6D6 must be, and a 6K7, kind of the same thing. 6D6, this is a tube substitution guide. 6D6. 6D6. Replace, you could put a 78. Wow, that's an old, and a 558AS. What the heck is that? Well, what happened to the 6K7 thing? 6K7. When you do this kind of work, you really do swim around a lot, in case you haven't noticed. 6K7. 6K7. So it can be replaced with all of a 6U7 or a 6K7, you know, with a different kind of like glass bulb on it. Nothing. Yeah. What's happening here? What is happening here? That's a good question. And you know, I think I'm going to call it quits here because it's actually after 12 o'clock now. It's a little late in the day for me to still be in here, so I'm just going to call it quits at this point. Not going to operate the radio. I'm going to ponder the finding that the schematic I have is a different tube set than the radio in front of me. How am I going to manage? No wonder I've been kind of stumbling around in here. Yeah. Okay, well, I'm just going to leave it like that. So that's as much as I got done today. Thanks a lot for watching. I certainly appreciate the company, and hope you watch me tomorrow. I will continue with this radio and sort out. It's a big discovery here today. I've really been off in the woods without knowing it. Thanks a lot for watching.